In the velvet cloak of night, when most of the world sleeps, a hidden kingdom awakens. These are the bats, creatures of shadow and mystery, whose very existence is a testament to one of nature's most incredible innovations. For millions of years, they have navigated the pitch-black world not with sight, but with sound. This is the story of echolocation, a superpower forged in the crucible of evolution. Imagine a world without light. How would you find your way? How would you hunt? Bats solved this puzzle eons ago. They became living sonar systems, painting a picture of their surroundings with echoes. The process is both simple and profoundly complex. It begins with a call, a high-frequency pulse of sound, often too high for human ears to detect, bursting from the bat's mouth or nose. These sound waves travel outward, a ripple in the fabric of the night. When these waves strike an object, a moth fluttering its wings, a tree branch, or the wall of a cave, they bounce back. This is the echo, but for a bat, it's not just a faint reply. It's a detailed report. The bat's exquisitely sensitive ears, often large and intricately folded, capture this returning signal. The time it takes for the echo to return tells the bat the distance to the object. The subtle differences in the sound reaching each ear reveal its direction. Even the texture, size, and movement of the object are encoded in the echo's acoustic signature. A bat can tell the difference between a juicy beetle and a falling leaf, all in a fraction of a second. This ability didn't appear overnight. It's the product of a long and fascinating evolutionary journey. Fossil records dating back over 50 million years show us early bats that already possessed the key anatomical features for flight and hearing. It suggests that the path to echolocation began very early in their lineage. As ancient bats ventured into the night, a new world of opportunity opened up, a sky teeming with insects, free from the competition of daytime birds. Natural selection favored those who could best navigate and hunt in this dark frontier. Over generations, this pressure sculpted their very bodies. Look closely at a bat's face. It's a marvel of bioengineering. Many species have complex structures called nose leaves, fleshy, intricate appendages that act like a megaphone, focusing their outgoing calls into a precise beam of sound. Think of it as a biological spotlight. Others have developed astonishing control over their larynx, the voice box capable of producing clicks faster and more complex than any other mammal, and then there are the ears. From the enormous, satellite dish-like ears of the brown long-eared bat to the sophisticated folds of the horseshoe bat, each design is a specialized receiver tuned to perfection. These bats can even adjust the shape of their ears in real time, fine-tuning their hearing to pinpoint a target with breathtaking accuracy. They're constantly updating a 3D acoustic map of their world, a world built entirely of sound. This evolutionary arms race wasn't one-sided. As bats perfected their sonar, their prey fought back. Some moths, a favorite food source, evolved ears of their own, capable of hearing a bat's hunting calls from a distance. When they detect an incoming bat, they take evasive action, power diving toward the ground. Some tiger moths even developed the ability to produce their own ultrasonic clicks, effectively jamming the bat's sonar or warning that they are toxic and not worth eating. This constant back and forth between predator and prey has driven the diversity and sophistication of echolocation to incredible heights. The world of bats is vast and varied. There are over 1,400 species, and not all of them follow the same acoustic blueprint. Fruit bats, or megabats, for example, generally rely on their excellent eyesight and sense of smell to find fruit and nectar. However, some, like the Egyptian fruit bat, have developed a simpler form of echolocation using tongue clicks not to hunt but to navigate the darkness of their roosting caves. This shows us that echolocation isn't a one-size-fits-all solution. It's a versatile tool that has evolved multiple times to solve different problems. In laboratories around the world, scientists are working to decode the secrets of this remarkable sense. Using high-speed cameras and arrays of sensitive microphones, they can visualize the invisible. We can now see the cones of sound a bat casts into the night and watch as it processes the returning echoes with neural speed that far surpasses our most advanced computers. Researchers are studying the bat's brain, trying to understand how it processes this flood of acoustic information without being overwhelmed. The insights gained are not just academic, they inspire new technologies, from better sonar for submarines to navigation aids for the visually impaired. The social life of bats is also governed by sound. Inside a bustling cave, home to millions of individuals, the air is thick with a cacophony of calls. Yet, within this wall of noise, a mother bat can distinguish the unique cry of her pup. Bats use specific social calls to communicate with each other, to signal territory, to find mates, and to coordinate their movements during a group hunt. They navigate a complex social world, all through the medium of sound. When a colony of bats emerges at dusk, it's not a chaotic swarm. It is a highly organized, cooperative exodus. Using echolocation, they maintain their position within the group, avoiding collisions even as thousands of individuals pour into the night sky. They create a living vortex of sound and motion, a superorganism moving with a single purpose: to feed. A single colony can consume tons of insects in one night, including many agricultural pests, making them a vital component of a healthy ecosystem. They are nature's pest control, a free and efficient service that saves farmers billions of dollars every year. Beyond pest control, bats are crucial pollinators and seed dispersers, especially in tropical and desert environments. The saguaro cactus of the American Southwest, for instance, relies on long-nosed bats for pollination. As they feed on the nectar of its night-blooming flowers, they transfer pollen from one plant to another, ensuring the survival of this iconic species. From the jungles of Southeast Asia to the deserts of Mexico, bats are gardeners of the night, helping to regenerate forests and maintain biodiversity. Yet, these extraordinary creatures face unprecedented threats. Habitat loss, white nose syndrome, a devastating fungal disease, and human misunderstanding have put many species at risk. We often fear what we don't understand, and for centuries, bats have been unfairly cast as villains in our stories. But when we look closer, when we listen to their world, we find not monsters but marvels. They are a triumph of evolution, a living example of how life adapts in the most ingenious ways. They remind us that the world is so much richer and more complex than what we can see with our own eyes. There are entire realities playing out in frequencies we cannot hear, in dimensions we can barely imagine. So, the next time you see a bat silhouetted against the evening sky, don't see a creature of the dark. See a master navigator, a precision hunter, a vital part of our planet's health. See a survivor that has conquered the night with the power of sound. The story of the bat is a story of resilience, adaptation, and the hidden wonders that surround us every day. And by protecting them, we protect the intricate, beautiful web of life that sustains us all. Thanks for watching. If you found this journey into the world of sound as fascinating as I did, consider liking this video and subscribing for more stories from the natural world.